201 degrees Fahrenheit. That is almost 94 degrees Celsius. We are completely skipping our usual intro today because, well, I want to drop you right into the fire. Literally. This number right here, this is the absolute highest ground surface temperature ever recorded on Earth. It was measured right in the heart of Death Valley back in 1972. Just to put that into perspective for you, at that temperature, the proteins in human skin actually begin to break down in seconds. The stakes literally couldn't be higher, and honestly, that's exactly the kind of shock to the system we need to set the stage for today's explainer.
So welcome to Earth Inferno. Today we're basically tossing the standard geography lesson right out the window. Instead, we're framing our own planet like it's this intense, high-stakes AAA survival game. We're going to explore exactly how humanity exists, adapts, and survives in the absolute hottest levels on the globe. Think of it as the ultimate test of human endurance against some really extreme environmental mechanics.
Level 1. The rules of heat. Every survival game has its core mechanics, right? And to beat the game, we first have to understand the environment we're up against, starting with how the heat that's trying to kill us is officially tracked by scientists. Okay, let's dive into this because there is a completely critical difference here that trips people up all the time. It's the difference between the air we breathe and the scorching ground we actually walk on. When you see an official weather record, on the news, it's almost always air temperature. And that is measured precisely 1.5 meters above the ground, totally shielded from direct sunlight. But compare that to ground temperature, the direct raw surface heat baking in the sun. This can actually exceed those air temperatures by a staggering 30 to 50 degrees Celsius. So when the weather app says it's a hot 45 degrees outside, well, the asphalt under your shoes could easily be a flesh-melting 80 degrees. Crazy, right? So what actually creates these insane, extreme hotspots? Let's break down the geographical game physics of places like Death Valley, California. It's a literal heat trap. The mechanics are just relentless. First off, you've got intense solar heating blasting down on dark soil through crystal-clear bone-dry air. Then, as that heat rises, it hits these steep mountain walls enclosing the valley, which trap the air and basically recycle it right back down to the floor. Add to that the advection, which is just a fancy word for migration, of already warm air blowing in from surrounding deserts. Top the whole thing off with compressed, superheated mountain winds called foehn winds, and you've got this perfect, brutal feedback loop of extreme heat. Level 2, the high score controversy. Now, humans love breaking records. But when it comes to the ultimate global high score for the hottest air temperature on Earth, things get surprisingly fierce. And this brilliantly illustrates how climate experts have fiercely contested and honestly had to correct the global leaderboard over the last century. Follow this timeline with me because it's a bit of a roller coaster. In 1913, Death Valley set a staggering record of 134 degrees Fahrenheit. But wait, then in 1922, Aussie Libya seemingly crushed it with a 136-degree reading. For 90 years, Libya held the crown. But then, look at 2012. The World Meteorological Organization officially decertifies Libya's record. They discovered it was likely misread by a totally inexperienced observer who was using an unfamiliar thermometer. Ouch. So that handed the crown back to Death Valley's 1913 reading, though actually, scratch that, even that 1913 reading is highly debated by modern experts today. What is undeniable, though, are the modern readings. In 2020 and again in 2021, Death Valley hit 130 degrees Fahrenheit, which stands today as the absolute most reliable, verified high score for extreme heat. Level 3, the endurance run. Because, sure, brief spikes in temperature are terrifying, but what about the slow, constant drain on your health bar? Let's shift our focus to the grueling reality of relentless, year-round average heat. To really grasp this kind of endurance, we have to talk about Dallol. This is a remote ghost town sitting 130 meters below sea level in Ethiopia's Afar Depression. Between 1960 and 1966, this totally barren, hyper-arid salt mining zone recorded an average annual temperature of 34.6 degrees Celsius. That's about 94.3 degrees Fahrenheit. And remember, that is the average for the entire year, day and night, winter and summer. Imagine living in a place where the heat is just this constant, inescapable physical obstacle, where there's virtually zero nighttime cooling to even give your body a chance to recover. It's easily one of the most hostile environments ever inhabited by humans. But here's the thing. Dallol is a ghost town now. What about the millions of people living the endurance run today? Looking at the modern leaderboard from Worldistats for 2026, we see the top 5 hottest, continuously inhabited cities. Just take a look at these numbers. Jazan in Mecca and Saudi Arabia, Khartoum in Sudan, Niamey in Niger, and Ouagadougou in Burkina Faso.
We are talking about massive, bustling urban populations across the Middle East and Africa, where extreme, sweltering heat is definitely not just some passing summer season. It is a daily, year-round reality that completely dictates how the society functions. Boss level, the Kuwait Inferno. Enter the final and definitely the most complex survival zone in our explainer today. This is Kuwait City, a densely populated metropolis that is actively battling an existential climate crisis. We really need to establish the sheer, overwhelming intensity of Kuwait's summer heat. We're setting the scene for an environment that is highly, highly hostile to human biology. In the summer, Kuwait City frequently touches 50 degrees Celsius. In 2016, it officially peaked at a staggering 54 degrees Celsius. At temperatures like that, you can't just stand outside and drink a bottle of water. Your body physically cannot cool itself down fast enough to survive. To keep going, the entire city has essentially had to adapt by turning inward.
But as you might expect, that adaptation isn't exactly a shared experience for everyone. Nearly 70% of Kuwait's workforce consists of migrant workers, and they're the ones actually building these massive indoor sanctuaries. This quote from a construction manager plainly and quite impartially observes the reality on the ground. Despite legal bans on working midday, laborers are often found toiling away on construction sites in 47-degree heat. The economic pressure is just immense. As the quote points out, if they decline to work, they won't get paid, and they'll be forced to return home. It's a really stark look at the human labor required to build a modern oasis in the middle of an inferno.
Now, what's really interesting about this slide is the vivid urban divide it shows. It's practically dystopian. On one side, you have the indoor experience, residents sheltering in air-conditioned cars, moving seamlessly into fully glazed glass shopping malls that are kept literally polar cold by heavy AC. It's like an artificial winter inside. On the completely opposite side, you have the outdoor reality, a workforce exposed to the dust, the blinding sun, and severe physical temperatures, building the very infrastructure that makes that indoor world possible. It's like a split reality, and it's happening every single day. Level 5, the price of survival. Because keeping millions of people in a state of artificial winter while the outside world burns, well, that comes with some massive draining energy costs. Let's look at how Kuwait has engineered itself into this massive, unsustainable reliance on oil just to fight the climate. It really started back with a 1952 master plan. That plan essentially threw out traditional climate-adapted mud bricks and replaced them with 20th century Western car-centric highways. Then came the fully glazed glass buildings. I mean, think about it, glass boxes in the desert. They basically act like giant greenhouses and demand unbelievable amounts of energy just to keep cool. On top of that, 99% of the fresh water required by the city comes from desalination, which is a massively energy-intensive process. And the government heavily subsidizes this whole system. Consumers pay roughly £2 for water that actually costs over £25 to produce. The financial and energetic burn rate here is just staggering. So the crucial point is this alarming 2030 prediction. Experts estimate that by the year 2030, a massive 30% of the oil produced by Kuwait will be needed internally, just for electricity and water production. Let that sink in. Nearly a third of their primary economic export will have to be burned domestically simply to keep the city survivable. It is a terrifying race against time and resources. Let's move to and see how this builds into their plans for the future, because they definitely aren't just sitting still. To adapt, Kuwait is looking at a $4 billion South Korean-backed eco-friendly smart city project. Look at the game plan here. Step 1, ditching that old car-centric grid in favor of buses and walkable spaces. Step 2, deploying advanced sensors to meticulously monitor and reuse precious water. Step 3, maximizing energy efficiency by controlling air conditioning systems across entire city blocks, rather than letting every single individual house max out their own AC units. It's a complete, ground-up reimagining of the urban environment to survive the heat of tomorrow. Which brings us to the end of our game, leaving us with a really provocative final thought. As global temperatures keep creeping up and more of our cities transform into these extreme survival zones, will this kind of incredible smart city technology actually save us all? Or, as we saw with the stark divide between those indoor malls and the outdoor laborers, is it just going to divide us even further? It's a very real, urgent climate challenge we all have to face as we step away from the screen and back out into the sun. Thanks so much for joining me on this explainer, you guys. I'll see you in the next one.